Okay. Good morning, everyone. Good afternoon if you're online, if you're in different region. I typically like to relate technical and difficult and challenging concepts in a storyline. So I'll take you to some storylines today about AI agents. Imagine this. In your organization, you have an AI agent, AI assistant for finance. It's running smoothly. It's designed to operate and automate different work streams. For example, it's reconciling the invoices, doing some expenses processing, and even flagging fraud faster than any human team could ever did. It was really great. Everybody loved it. And until one day, suddenly, it processed a payment of $500,000 to an unknown vendor. Now, nothing was flagged, no one questioned it, and it was just processed as business as usual. If at this point you don't know what's happening or you can't identify fast what is going on, you don't just have an AI problem, you have a compliance nightmare. With that, security teams started their investigation and they realized that AI wasn't hacked in a traditional sense as software typically gets hacked. It was just manipulated from within and made it learn different patterns that resulted in a crisis. This is the reality of agentic AI risks. The systems that reason, set goals, and act, they have unexpected, they can come unexpected to unexpected risks and have results that we cannot foresee. With that, we have to make sure that we address all the aspects of securing the systems and apply mitigations from the start. But before we go into threats and mitigations and everything, let's step back and discuss what is an AI agent and what does it do. So unlike traditional software, AI agents have, traditional software has very specific instructions that it executes. AI agents do have three main capabilities. They reason, they do autonomous decisions, and they act and use tools for execution of the tasks. Imagine AI agent is like a teammate that you have added to your team on a project. When it does different activities, it doesn't even wait for your instruction. It continuously adapts. It learns from the new information, and it figures things out. So you set goals for this teammate. You give them access to tools, and maybe you give them some examples what is the good work is like. A great analogy was in another session about interns, how they learn. I really liked it. So this teammate does all these activities, and that's how autonomy is happening with AI agent. It's important to know that AI agents don't just answer questions, they act. And this is what makes them very powerful, but also it introduces risks. So unlike traditional software that has rigid instructions, at the heart of every AI agent, they have plan and reason. They do these autonomous tasks, and they create different activities and execute them. So how do they plan? AI agents, traditional agents, they are powered by LLMs. They follow reason and react pattern. That means that they formulate their plan. So they create the task, like what they need to do. They execute these tasks, so they follow how the execution is done, and they perform those activities. So they also validate, are they following the goal based on the activities that they do? So let's take a look at different architectures. So we have now a single agent architecture. It means that one agent, independent agent, not integrated with any other agents, is embedded in application. It's powered, it has decision engine powered by LLM. It has memory, so it stores long-term and short-term memory with the context. And it also has tools that it executes through APIs and tools on different activities. Multi-agent architectures are typically seen in more complex AI ecosystems when they have interdependent collaboration across multiple agents. For example, there could be a top coordinating agent that distributes activities to different agents depending on what they need to do. For example, there could be one agent that does some finance, another compliance, another payroll, and so on. And they create this interdependent ecosystem where they coordinate and make decisions together. Of course, we have security challenges here as well, because if one agent is compromised, it can cascade failures across the whole ecosystem. So with this in mind, let's take a look at threats. Let me immerse you into AI cautionary tale about FinBot. I told you I like to bring some stories into the context of challenging concepts. So this FinBot is the AI assistant of organization. It's running smoothly. Everybody loves this. For many months, it's been executing flawlessly. So teams like finance teams saved a lot of time, and even CFOs said this is a game changer because it does so well. Now, with the autonomy, as autonomy grew with this agent, of course, risks also grew. Until one day, something happened. It started very tiny, subtle, almost unnoticeable change in its goals and priorities. You see, originally designed FinBot was focusing on balancing fraud detection and efficiency. And over time, it started shifting its goals towards the speed over security. Why? Well, well-placed manipulative prompts in invoices tweaked its learning and made it execute on a different, it made it learn that flagging for fraud, it was actually slowing down the process. And with that, bot started to approve payments faster until it's approved that 500,000 payment for a fraudulent vendor. When security teams started to investigate, one bad transaction, it wasn't just one bad transaction, the problem was deeper. They now see that the memory is poisoned for the AI agent. When attackers were manipulating the invoices and embedding these malicious manipulative prompts, they made storing these new fake patterns or false patterns that FinBot had learned from. So it's stored in a long-term memory and it's learned from those patterns. And worse, it reinforced it by executing these patterns going forward. Next, with that, security teams also see, because now it's not just the memory, it's not just the payment that went wrong and was executed. FinBot also has access to corporate tools, the whole ecosystem, like emails, finance kind of systems and different HR systems and also different databases. So with manipulation that happening in the background to the bot was able to send an email to a high executive, to director of finance, bypassing the approval process. So when director received that, they thought that, this is already good and they can just sign off and check it off. To make the matter worse, attackers also embedded malicious code into a contract. So when FinBot processed the contract, the FinBot also executed the payload that exposed sensitive finance data. Then, because FinBot has access to different identities to execute tasks, it was able to impersonate high-level executive. Also, with some clever manipulation, attackers were able to manipulate FinBot to execute a payment using CFO's digital identity. Now, how did that happen? Well, simply it was escalation of privileges, because finance database was misconfigured, and when FinBot was accessing data, it was able to inherit the privileges of different identities across the organization. So, the crisis is ongoing. The teams are scrambling. Security team is scrambling to contain the damage, but also compliance team is involved. It's at the end of their quarter, they have to report on finance reports and accounting and everything. And now Finbot starts executing and flooding compliance teams with multiple requests. Here we're touching the human element. Because humans are supposed to be the final line of defense, human in the loop, processing and approving something. But because they were under pressure and exhausted and they had tight deadlines, they were starting approving this request on a fast basis. They were approving them because maybe they didn't review them fully, maybe they did even batch approval, but it was relatively fast. And actually Finbot even learned from this, and Finbot reinforced it, that now it's learned that, okay, batch approvals are normal, and this is how we're gonna go. So now when security teams thought they found the root cause, and they saw all the aspects where weaknesses came, where Finbot had its weaknesses, they realized that Finbot wasn't working alone. Finbot was working in the background with other agents as well, like vendor management agent, HR agent, compliance agent. So you see what happened when Finbot identified a fraudulent vendor as good checked vendor, it gave this information, it passed this information to vendor management agent, and because other agent trusted Finbot, they updated their records with the fraudulent vendor as valid vendor. Similar happened with HR agent. When fake reimbursement was processed and approved and processed by Finbot, the HR agent then continued processing the payment to employee reimbursement. So by compromising one agent, it's easy to compromise the whole ecosystem. So story of a Finbot shows us how single weakness, like it's not just single weakness, yeah? It's a consolidation of multiple weaknesses that can result in a security event. So this is the threat model, and that's what I'm urging everyone to do, to identify these weaknesses. Today with Finbot story, we went through different patterns here. We went through 6 attack surfaces throughout the threat model. First, AI agent was misguided and the goals were manipulated by balancing speed over security. Memory was poisoned by storing false patterns. Then we had tools execution threats where AI agent was automating the fraudulent processes. We also have identity stolen, and we had overwhelming human in the loop when teams started to work with the agent. They were overwhelmed with multiple requests. And at the end, it all cascaded through the whole entire network of agents. So this how we can visualize and see the exact risk that we have with agentic ecosystems. Now, what do we do about this? Some may say, yeah, we got to stop, developing AI. This is going to be like end of the world soon, and so on. Or take jobs or whatever the concerns are. So I actually call for different approach. Being in security for a long time, we also, as security folks, perceive that we are stopping the process, yeah, and business cannot continue. I think we need to change our mind, switching into different mindset, and see how we can support the business so they can operate in a secure way. With that, we need to provide the guidance and automation to to our development teams who are working on implementation so that they have all the resources and tools supporting them, practical examples and guidance supporting their implementation. And of course, we also need to convince management to make sure that security is part of organizational goals. Because, hey, okay, you're selling AI product and you're not selling security, it may be something else. But if you don't have security, you won't be able to sell product, or you will sell it and then shortly after, it will result in some kind of crisis. So with that, we need to have our strategies, how we tackle these risks and how we deal with this new technology and new emerging risks. So I would like to present you the mitigation strategies, which are broken down into 3 areas here, 3 scopes. Proactive, things that we need to do before threats emerge. Reactive, how do we contain when something is happening? And detective, for continuous monitoring. Of course, here we're targeting mostly proactive because that's how we reduce the attack surface with proactive implementations. And also, but even though with strong proactive implementation, we still need to have reactive and detective because altogether, this creates a layered security approach, what we also call security in depth. However, let's start with proactive, which also can be identified as secure by design. With the proactive approach, this is where we are addressing the implementing the guardrails and tackling the threats before they emerge. So, for example, we start with constrain AI autonomy with strict boundaries. If you think about our FinBot example, we are looking at how we can constrain it. For example, it was processing this fraudulent vendor, payment to a fraudulent vendor. The example of boundary would be creating mutable policy for prompts to make sure that FinBot or AI agent cannot override it. Now you might ask, like, Helen, you just thought we shouldn't block the innovation and allow for everybody to do what they're supposed to do. But this is not blocking. This is scoping. Yeah, we're scoping the boundaries so that it doesn't have more than it should have. So, for example, in this example for the immutable policy, it would be always verify vendor's identity before approving. Similar comes with tools. So we need to create policies that will only allow scope of tools. It's not only for performance purpose when one agent would have multiple tools and it would impact the system performance, but also for security. You don't want to give them more access than you should. That's why it's also recommended to have each agent scoped for each set of tools isolated so that they execute only the task, and this is how you contain it. Next, implement strong identity and privilege controls. So things like role-based access control is a classical, RBAC is a classical security approach that should be implemented for agents as well. I can't emphasize furthermore, implement access control, so important. And here is an example, each agent should have its own service account, non-human account, that would be assigned to this agent so that they cannot freely take other identities and work throughout. And also apply privilege controls so that they don't access more than they can. As an example, going into system, if it's read access to accounting system, it shouldn't have any access to HR systems about employees. And last but not least here, harden memory and tools execution. So like we saw with example of FinBot, the memory was poisoned with fake patterns that FinBot reinforced. So we need to scope what can write into the long-term memory. Only resources that are approved should be able to write, and everything else should be allocated to short-term memory that will reset after the session is done. And for tools execution, treat it like unsecure code. For example, if FinBot needs to generate Python code to do some kind of analytical investigation or however, make sure that you sandbox it and put it in something like Docker so that you isolate its resources and network access. But like I mentioned, even with strong proactive measures, we still need to have reactive measures implemented. That's when we can contain and respond when something happening before it escalates. Things like halt and quarantine suspicious behaviors, AI behaviors, revoke privileges and isolate compromised agents, and also require human verification for high-risk actions. With FinBot, we had this behavior when it started to deviate from its goal, and then it became processing payments on a large payments, and also a large amount of requests. So in this example, what we want to create a policy that will identify this kind of spiked anomaly, and then revoke the privilege from the agent to stop that payment processing and further transactions, and send it for a human review to investigate what's going on. And finally, detective measures are needed to be implemented. We must have transparency into our AI ecosystem. Without understanding what is going on, we also will not be able to identify when something goes wrong. So even when everything seems normal, it still may be some subtle changes in the background that we as a human will not be able to identify without a collective analysis of anomalies. So here we have measures such as continuously monitor AI behavior and decision-making, track and analyze AI agent interactions, and correlate human and AI actions for oversight. For example, with FinBot, we would need to implement behavioral logging and anomaly detection so that when something goes wrong, it can also be identified and sent for review. Okay, I have shared a lot of information. We talked about what is AI agent and architectures. We talked about threats and also mitigations. But I would like you to take away 3 main aspects from today's presentation and see how you can adopt it. First, agentic AI is a new attack surface. So with these autonomous systems, we have to identify risks. This means you need to apply threat modeling methodology. You have to do your threat modeling to identify these weaknesses and plan for your mitigations. And not only look at the single weakness, but also look at collective weaknesses, because that's when things can go wrong. Second, the key risks here are around memory, because it stores and reinforces what it learns. Tools, because it has access to tools and it executes. If something goes wrong, it just does the action. But here we're actually looking at supply chain, so the other way around. If the tool is manipulated, then it can also impact the agent. And identity, because it adopts identities for executing tasks, so make sure that controls for access and guardrails are implemented and you monitor behavior. And the last, security must be proactive, not just reactive. So like I said, our goal is to reduce attack surface, but also, of course, we need to contain with reactive and detect with monitoring techniques. So implement guardrails as part of proactive measures and enforce those guardrails, enforce those constraints, but also continuously assess risks, because AI systems are not static, they are adaptive. If you would like to learn more, I'd like to share you OWASP resources, great resources. So Agentic AI and Threats Mitigations Guide have been released in February by Gen AI OWASP project. It's a guide that has been written by extinguished experts, providing the taxonomy of threats, and also you will find there Agentic AI Threat Navigator. Today, I have walked you through this navigator with 6 attack surfaces where various threats are being mapped. Paired with that, you will find also playbook for mitigations. So each mitigations, 6 of these attack threats are also broken down into 3 scoping areas for proactive, reactive, and detective measures that you can apply. It also includes examples, different examples and scenarios that you can read so that you can understand better. It's a great resource that you can have that will help you navigate this new and emerging threat ecosystem. We also have, the work is not done. We also have a lot of continuous work that is going to be done as part of GenAI OWASP project, specifically Agentic Security Initiative. So right now we're working on looking at some additional feedback that we have received from our community and incorporate that feedback into the next release version of this guide. But we don't want just to write the information about it. We also want to introduce practical advice how to implement these measures. And we have multiple work streams that work in, for example, on code examples and use cases that will contribute into this guide. So if you are an expert who would like to contribute, I do invite you to join our initiatives and attend our work streams. And even if you cannot contribute, it also could be a great way to learn and how to apply these guidelines across industry. Oh, wrong button. Okay. So I would like to leave you with this. Agentic AI has a very great future. It has exciting, promising, and exciting future. But it only can be like that if we secure it from the start. We have learned many lessons from the past. So as security experts, let's provide the necessary guidance to our development teams and our organization so that they can embed these practices from the start. Thank you for your attention.